Thank you for a kind introduction. And yeah, that is a bit about me. I'm working with Scala for almost 10 years, so I guess I got a lot of experience there. But we'll see if I will be up to answering all your curious questions. So we can I can go to the actual talk. I'm comparing Java and Scala here. We will have some introduction mainly to Scala. I wanted to say that I'm not a Java programmer really. I worked with Scala on commercial projects, but in Java just a little bit. So I needed a bit of help. And my colleague Eva Kubranska helped me a lot with this, so I want to thank her very much. She was very helpful. So let's have a look at what we are going to do today. We will have a look at some kind of high-level comparison. What are the languages for? What is a bit of history of the languages and what they kind of tried to do? Then we will have a look at Scala syntax, very basic one. We won't go to kind of like very niche things, and maybe I will explain something out as we go through the code that I didn't show before. But I try to make everything kind of understandable. If something is bugging you, please use our chat. We will have a look there at time to time, and we can adjust. So let's go. So high-level comparison of the languages, Java and Scala. Let's talk about what is common here. They are both JVM languages, which is, I guess, not too surprising for a lot of you. On JVM, we compile every language to bytecode, and then it is interpreted. So this is kind of a similar way, whatever language on JVM we are using, whether it is Kotlin, JPython, Java, Scala, it is all the same. Both languages are quite strong on object-oriented paradigm. So we got classes, we got interfaces, or, well, they are maybe named somehow differently, but we've got instances, we've got objects, we've got all of that, we've got methods. So this is quite similar. And also, both languages are quite good in static typing. So it is not like, let's say, JavaScript, when the value can be anything. We define what values we are using, and then we can control our code a bit more granular, I would say. It is, of course, tool static typing. It is whether our situation is to be, well, the tool is to be used in our situation or not, but this is something that Java and Scala are very good at. So let's have a look at differences. And I kind of went through a bit of history, and of course anyone can Google that, but just to see the time frame is kind of, it is easier to understand how those languages connect to each other. Java was founded in June 91, I found, and I found even some other dates, so maybe it is not like the best answer there is, but I found this one, and it was created in a company, in an organization, Sun Microsystems, and this language that was created was meant for this type of electronics, as I'm mentioning here, TVs, set-top boxes, this kind of living room appliances, let's say. In 95, it was released officially, and everyone can start to code in Java. Scala had a bit different way. It was first created at 2001 at this Switzerland university by, main person there is Martin Odersky, and well, as it is university, it was kind of academic approach. Odersky himself created some Java compiler, and he was quite interested in languages in general. And as we all know, any tool has its flaws, and any tool kind of learns its flaws a bit too late, even after it is used, and it's a bit too late to be perfect. So Odersky tried to learn from what he considered flaws in Java language, and in 2004 he officially released Scala as a programming language. The philosophically main difference between Java and Scala is in paradigm. They are both very good in using object-oriented paradigm, but Scala leans heavily on functional paradigm, on functional side. I think this kind of created this notion that Scala is very difficult and academic, and there is a lot of math involved, and that it is just quite hard to learn. And I think the paradigm shift is non-trivial from object-oriented to object-oriented and functional, but I would say that as any way of thinking, it requires a bit of practice, but afterwards there are some benefits of it, which Odersky had in mind, and which Java founders in 91 or 95 didn't had opportunity, even because as even in this, let's say 6 or 10 years, the technology changed a lot. So what we are using now are different, but even better suited for our technological world as it was 10 years ago, let's say. So let's have a look in Scala syntax and what we have here. So class is like reserved word, and in Java it is exactly the same. It is just a class. And that's the same. Then we've got objects. Object is quite nice thing, because in Java we've got these static methods that don't belong to instances really, but to class in general. And the static and non-static methods can be kind of at the same place. And in Scala there was there was a decision that we would have singleton. It is written just as class. It is just object and my nice object as a name of the object. And this is the place where you would put all these methods that should not be part of instance, but should be part of the class. So there is even interesting thing. If you name object the same name as is a class, we call that companion object, and then we can use even private methods from the object in the class. So this is kind of special relationship, and it kind of it is very common to have class and then have object alongside. Does still make sense to learn Scala? Yeah, we will get to that. We will get to that. So then another thing is trait, that is like interface in Java. I remember times when interfaces interfaces weren't allowed to have the implementation, but I know that this is no longer true. But this was the decision for Scala from the beginning. So trait is very similar as an interface, but you can have implementations. You don't need to have implementation, so you can work with your code a bit more freely. Then we have something called case class, and the closest thing that I found in Java is called records. As I understood, records are not very long in Java world, but you got toString method for free, some apply method as a constructor, and you got the getters that applies for case class in Scala. We will get to why we don't have setters actually, but that would be not so much of a syntax, but more of the philosophy of what we are trying to do. So yeah, and I know that you are all muted, but I feel like you are very, very happy about this slide. because we don't need semicolons, we don't need to return, or we don't need null, and we can have them. And actually, there is this thing that well, as a Scala programmer, I am able to write Scala in any programming language, and I know that Java programmers can write Java in any programming language. But the idea is actually that the semicolon, we can use it, but the end of the line is actually the semicolon. It is the end of the expression, the end of the statement. So if we would like to have multiple statements or expressions on the one line, we would use semicolon, but I did never use it in production code, maybe in something very small, but even though I don't think it is any useful to have multiple expressions at one line, why would I make code less readable like this? So the semicolon is something that you just don't need to use. Then we don't need to return. And we are returning values. We are returning values all the time, actually. But return methods of a code block would be last evaluated expressions. That has its, that means that even something like if is considered the expression, and what if is returning, that is actually what is returning. So typically it is the last line of the code block. And also I did never use return in production code because I just wrote the method in a way that it ends at what I want to return. So this is something very common. Well, null is a bit more interesting or a bit more tricky because null actually, well, again, exists. But instead of null, we are trying to use something called option. And I know that in Java there is optional, and I hope that you are using it. But with null is just a nasty value that doesn't do anything very useful. With option, we always can decide whether we are using the value or we don't. I will show how we are using it in very basic example. We will get to it in a minute. So those three are not needed. Well, of course, there are some places when you are reading like a lot of files or something like that, then you can just have on reading side nulls and then just map it to something more reasonable. But that's very much in application logic. So yeah, absolutely. So this is a bit further. So we've got three ways of defining the expressions, and we don't need to put a type in front of the expression. We can write it just as you can see here. Variable foo is my immutable foo, and that's pretty much it. And if you are doing something small or something labeled as private to the instance, to the trait, whatever, then maybe it is not too important to put the type on everything. But if you are doing something public, it is best practice to put a type on it, so any client can work with it. So there are three types of expressions. Maybe we can find more, but those are basic ones. So there is a var, that is variable mutable value. And if you just go, get a value in and then reassign, this is very much all right. In Scala, we are trying to avoid vars as much as possible. Because of the functional paradigm, we want to have as much as possible immutable. Sorry. So you can have variable and it can be quite useful, but always have it private, have it somehow protected from the outside world. if you got variable, if you got some state of the class of the instance, then you need to, well, it's best practice to guard it, to let only the instance that owns this variable to change it, not someone from the outside. Then there is value, and it is how it sounds. It is value that cannot be changed because, well, it is value. It is something bit similar to string in Java, that you can't really change string, you can just create a new one. And this is something that is done in Scala all the time. And so first ones would be evaluated the first time they are read by compiler, but def is actually method. It's short for definition, and it is executed every time we call it. So this is some increment for number. And also I could just put here the return time, but I don't need to. So yeah, and then this is the most advanced part of syntax that we will go through like this. And this is pattern matching. From a Java perspective, it is switch statements, but it's quite powerful, and I can do a lot of stuff with that. So I'm matching against my variable, and I can, there is just one value that I want to use, so I can even check any predicate on this value and then continue with anything I would like to. If I can have second filter, then I can have something that I will still use the value, but I kind of don't care what for any filter or something like that. I just do something with it. And I can have this underscore. Underscore is also quite powerful thing in Scala. And this says default. If anything else failed, if it didn't continue with any path before, this will be what will happen. So this is like wildcard in this case. And also this is for actually case classes that I mentioned before, that I can just match against my instance, and this will be name of my class, and I would have arguments of this class. I can have arguments that I need to use, then I have them named. Those that I don't need to use, I can have just these underscores. So I can match against the constructor, basically, of my class, and I can, just like this, take out the arguments. I don't need to do like my class dot argument 1 or argument 2. I can just take it out as they are. So this is one function that needs those 2 arguments. This is other function that needs only 1 argument from some other class. This can be instance of some trait as it is interface, and I can match against the interfaces implementations or something like that. There are ways how to do it differently, but I'm just trying to show you this pattern matching. And also this is a bit different, but if we've got sequence, we can kind of pattern match against sequence like this. This would be some operation on the sequence, and this would be first element, this would be rest of the sequence. So let's say this would be integer, and this will be sequence that left, that is without this integer, and then I'm just doing something with it. So if it doesn't make sense, like completely, why would I pattern match against some classes and then against the sequence? Then you are a very smart person. This is just so I will show off a bit of pattern matching. I hope you like it. So let's have a look at code that I prepared for you, and we'll see. Welcome. So on the left side of my screen, I have Java library demo, and on the right side, we've got Scala library demo. When I was in university, we needed to create projects, and they forbid us to use library as what we are going to do, because it's like too intuitive. So I have to use it, of course. So let's have a look, and I will have it like side by side so we can see the differences and similarities. I've got two flavors of the implementation. Let's start with the basic one, and then we will call to one that I called members, and we'll see. Okay, so I've got basic implementation, and then and in that I've got model. Model is an important part. So we've got this, and we've got book, and then we've got library. So book isn't fancy at all. It's just like this. I'm using records. I mean, not sure if is it good practice to write camel. Yeah, I will answer the questions later. Even my eyes are drawn to it. We will focus here. So, public record. This is a book. It has title, it has author, and it has a year. It is not like most sophisticated one, but it is what it is. Then we've got book in Scala, and I would say that they are quite similar. I've got case class, I've got book, title, author, year. I don't have these curly braces, but I mean, it is not like the biggest difference in the world. They are pretty much the same. Okay, then I have library, and it is a very basic library. Let's not pretend that I spent 2 years writing this. We've got just some list of books. I want to have it private, so just library can access it. Then we've got some constructor. Then we can add a book, and then we can list all the books, and we can search for the books by author. I use this stream and filtering, and I'm sure you all are using it everyday basis. Then we are collecting it on the collector to list again, so that's pretty much all right. We equals that book author is something that we got as the argument, and well, of course, there is the size of our library, because we want to know how many books we have. So what I did here, I created something very similar. I mean, it's a bit less of code, and it's a simple implementation. I mean, it doesn't do too much. So here I've got books, and I've got it in variable, and I didn't want to create any database or anything like this, but let's play like, yeah, this is the database of my books, exactly like here. I mean, we don't need to make it too big. This is just enough for me. I hope for you as well. So I don't have the constructor, but but this is actually what I do. I am just initiating it at the start. I got this feeling that maybe I need to do this in Java anyway. So that is something that I just initiate when the instance is created. Then I have add a book. Here we've got this mutable list. So I'm adding book right to this list. But what I actually doing with here is that this is actually not mutable list. It's immutable. But this is just a variable that points at this list at the beginning. When I'm adding a book, this is the operator that I showed you before, those two double dots. And this is adding new book to the other books that I already have. And this new list, again, a new immutable list, is stored in this variable. So this is what is happening here. It is subtle difference, but is very common in Scala. All the time we are just creating new stuff from the old stuff. Don't care about the old stuff. Let's the garbage collector collect that, and we don't care. We just want new instance and new stuff. So we just list books, and yeah, I don't have a return. I hope that you are as happy as I am. I don't have a return or semicolons. I'm just returning the books because I'm listing the books. Then I'm citing books by author, and I think this is very nice about the Scala, that we are filtering very, very intuitively. I don't need to collect on anything. I don't need to change it to stream. I'm having the list of books. Filter is actually its method on the list. Let's not look too much on this scary stuff. And then we just compare. And this is another use of underscore. I don't need to name the books I'm going through. I'm just saying that for all the books that I'm having in this list, check the author and let's compare. So this is pretty neat way how to do it. I wouldn't need even these curly braces, but yeah, if there are a lot of small methods, I like to just have it around so I don't accidentally parse something around and lose the implementation or something. Of course, there are tests and compilation, all of that, but it kind of, I like it a bit more. This is not something that I needed to do. And also count the books is pretty much the same. I'm not returning anything. I'm returning this, but I don't need to say it because I'm just having it. Now I was looking at it, yeah, this library is a bit shorter, and this is a bit of a selling point. Because Java can be a little bit more verbose than Scala. Of course, you've got all this fancy stuff as Lombok or something like this that you don't need to create setters and getters. You've got records here, so there are solutions to do. But you need some tooling, some extra tooling on it, and with extra tooling, you need to watch for versioning, and you need to have this tooling at your hands, and this is all just the classic Scala. You don't need any library, nothing special here. But as a Scala programmer, I was looking at it and I was like, yeah, it's all right. And for this presentation, it would be, I mean, a bit boring, but also, yeah, if my point would be just, yeah, Scala, do it on less lines than Java, then I could just say, yeah, that's nice, that's fun, and we can go to the questions and go home and all that. But we will not do that. We will have a look at what I created, because this is pretty much the same implementation. And I don't think it's too much, it's too functional. And I like functional, because functional for me is something like taking control of my operations. And I will, yeah, you are looking at it for a while. I will give you like 10 seconds and maybe try to answer for yourself what is not too functional here. And let's say that this variable is all right, because this is actually some database that we are storing things in. And if you are even asking yourself that, what is this? Then I will say to you that, let's say that it is exactly same as a void. This is unit. This is actually some object. And this is what we return when we don't care about the result of our method, of our operation, of our process. This is something that we don't like to do in functional programming, because functional programming is not mathematical thing, really. It is not like too complicated. It is not that you have to be like super smart for it. And I know that because I'm doing it. So what functional programming really is about in a big part is that you need to return some value. You want to return some result just to say to your client, this operation was successful, this wasn't successful, this is something happened. And it doesn't need to be like exception or something like that. Exception-driven development is not like the best thing ever. Well, it's actually quite a bad thing. So it is more about this happened in the process. And that's why it's kind of functional, because function is that you give it some input and you get the output. And without the output, we kind of don't see the point of computing function because we don't need the output. So this is kind of the thinking that I'm trying to present here and that I use every day as a Scala programmer. So I was looking at this and I created functional library here. So what I did, I wrote a lot more because I got this feeling that you would appreciate. And what I did, I can point just some things out. I created a functional library object. It is not everything just in the instance, but I wanted to have something extra. And what I actually created was book addition result. And it might feel a bit arbitrary, and so yeah, you're right, it is. But it gives me the control about my call to add book. It is not like edit this book and I don't care about anything else, and I don't know what happened. Just kind of I cannot react to the result of what happened because your method is saying, okay, I'm taking the book and don't worry about the other stuff. And well, I mean, for some small things it might be right, but it's not what we aim to in functional way. So, and I admit I added a bit more logic because I wanted to use this fancy if statement. So what I did is that I created set of the banned book titles. I didn't want some books in my library for any reason. And to be honest, I'm not fan of banning books, but yeah, I just felt it in the moment. So I created set of books because I don't want to have multiple same books in my library. I want that to be, let's not think about like multiple pieces of books. Let's say I want one book just once. And then I got here to my companion object. Here are banned book titles, and I got just one. So this is private, but I'm still able to use it in a functional library because the names are the same. And so what I created is book additional result, and I mentioned that there is trait as an interface, and it is often used like this, like some kind of enum. At least in the Scala version that we are talking about, it's like second version. There is third version, I think, like 5 years around, but this library is written in the second version. And yeah, I created the result, and I was like, okay, we can have success and we can have failure. This is like kind of basic approach. What result could be, and of course it can be kind of mixed, but let's not worry about it right now. And I created like failure is just failure. I created success, and in success I went a bit deeper in the logic, and in the object I created these case objects, book edit successfully or book already present. I was like, okay, someone is giving me the book and I already have the book, so I won't care about it. I don't have more books than before, but I already had this one. So if someone, that's the point. Then we've got book failure, and the only thing that I could add, and of course because of that I created these banned book titles, is that this book is banned, and I don't want it in my library. So that's pretty much what I created here. I admit this is a lot more code than here, but I would argue that this is a lot more business logic than here. It is not like I'm writing code just to make something run. I'm adding some business requirements that my client came to me and said, yeah, I want some books to be banned. I want to have some better response from my additional book because I added the book, but then I counted it and it wasn't one more or something like that. Whatever, client and business is the king, so we need to make it happen. So this is my functional library. I hope you like it, because we will go to the next level, and the next level would be that I like my basic library and I've got some books, and that's all right, I guess, for the library. But I didn't have anyone to read them. Someone could add a book, and that was it. So it was like box in the library or something like that. So I created something more advanced, and we will compare it again. So I created very simple book, again the record, and there it's genre. This is the fancy new thing that my client wanted from me. Okay. I kind of, I mean, we are programmers, we want to see something that is running, right? Let's run it. So I created some public static void main, as always, and we can just run it, and I hope that it will run even here. Yeah, it does. Okay, so what I just kind of created is, no, this is not the right one. Sorry for confusion. Yeah, we should be in basic, so that's all right. So this is very short one and nothing fancy really. I am just created some. I edited 3 books with very imaginative titles and authors even more so, and then I have all books. We've got it like this. This is for those who don't know records very well. This is how you got 2 string from the records. This is how it looks like. You got the argument name, and then you got the value, and you got a bunch of them. And then I have some books by author 1, so I got 2 of them, and I've got here title 1, here is title 3, and I don't have title 2, so I'm filtering correctly. This is nice, and I've got the number of books, so that is all right. And I sneakily will run this. I don't need to create any kind of main or whatever. I just extend this app trait, and this all will be able to run just as a public static void main. It is basically the same under the hood. So it's here. Okay, so I've got library. I'm having a book. I've got some. I've got banned book. So I edit first book once. I've got this. It is all right. I edit it second time. It tells me the book is already present. So this is kind of granularity of control that I'm looking for. Then I edit some more books successfully. And then I try to sneak in a book that is banned in the library. And it didn't work well. It just told me that book was banned. So we've got all books, and this is the 2 string that case class is creating. It is a bit more concise, but you don't see the name of the arguments. Maybe you want it, maybe you don't. That's, I mean, for me, it was always kind of good enough. So we got this first one, we've got second and third. So there are two books exactly like on the Java side. I filtered by author, and yeah, it is quite nice. We've got author 1 in 2 of my books. I filtered for author 4 that I don't have any, and I have 3 books in the library. Pretty much the same stuff. A bit more business logic, a bit more is happening on the Scala functional library side, but I think it is very comparable. So now we can go to my other fancy thing, and yeah, it is the book. It is basically the same. It is nothing really to be scared of, and very, very similarly it is here. Here is the book. This is the book. Nothing fancy, just genre as a new argument. Very nice. Then we have a member. So member is a bit more richer, and this is actually what you, well, yeah, your Java programmers, this is what you can do. So member can borrow a book, and member can return a book. This is not exhausting, but we've got the members, so I hope you're happy. And I've got member here. So we've got, again, we've got some list of books that is like area list. And in the class, this is just a bit different, but this is a private var again. Let's say that this is some kind of database as before. And here we see actually that this list is mutable. We are adding, removing, we are just working with the same list all the time. Here we are reassigning. This is kind of niche, but if you want to understand the Scala properly, this is what you are actually doing. And we've got mutable versions of the sequence and the lists and all of that, but they are used a lot less. So I mean, if you need some performance or something like that, when you are working with a big bunches of data, can be useful, but I didn't encounter such a situation really, so I guess it is not so common. But of course, you got to think about what you're doing when you are programming. It is not like it is just intuitive. But if you are just typing sequence like this, it would be immutable. If you are typing list, array, whatever, it will first it would be immutable. If you want a mutable variant, you need to import it separately and use it as imported separately. So that is the difference. Okay, so let's have a look at our library here. A bit more. Yeah, I can probably just close this. And there is a bit more, but it's not like super different. We've got books and we also got members. So that's nice for our library. We're adding books, we're adding members in exactly the same way. But we've got something, well, we are borrowing book. And member has its membership ID, name, and how much books, which books member borrowed. So I use this optional, and I hope you know it. I use it. I think it's a lot better than now. And I've got optional member because I'm trying to find a member, and I don't have any control about this membership ID. So it is very much valid to look at the database, have a look at the members, and yeah, I don't know you mate. So it happens. But after that, if the optional is present, and if the book that is tries to get, and of course there can be book ID or whatever, but I have it simple. So I'm checking whether I do have a book, and if I do have a book, I'm getting the optional member, and he's borrowing the book, as there is a method on the member as we see before. Then I'm removing the book from my library because I have just one. I got just one book of the type. So returning is very much similar. I've got the optional member, always have to check whether the member exists. Then if it's present, it returns the book, and I got the book back. I'm listing the books, that is very, very similar. I'm listing members, very similar. I'm finding books by author. It was there before. By genre, it is basically the same. Nothing fancy happened here. I've got count of books and members, also like just some very dummy statistics. And we've got find member by ID. So I'm filtering in a very similar way as before. I can create this like some generic method and use it. I am aware of. So on this side, okay, just other tabs. Yep. This side, I've got member. Book is basically the same. Member, right? And also I've got library. And I guess you know now that we will have another version. So we've got this edition of book, edition of member. We got them in variables, so we are just reassigning the new sequences. Actually, yeah, sequences. Good. So that's all right. And I'm borrowing a book, and I think this is a bit simpler. I'm finding the member, and find the members is just members find by the membership ID. So there is nothing else that the business logic here really, apart from maybe the dots and the parentheses. And I'm using this. And if I found the member, then I'm taking the member. And if I have book in my library, the member is borrowing the book. And yeah, I'm creating a new set of books, and I'm filtering the book that member just took away. Kind of makes it. If member is returning the book, pretty much the same. Find the member, and if I know this member, I can then take a book from him and add it to the books as before. Listing is as boring as before. Finding books by author, by genre. Yeah, again, just the one line of filtering, nothing here. You can just read it as applied English, really. So that's very easy on the eye. I don't need to kind of focus that here is the logic, here is not, whatever. This is just pure logic that we have here. And I, again, looked at it, and I mean, it's nice. It's a bit shorter than this, I would argue, but I mean, it's a simple example. I would say in a complex example, it can be even shorter, and the difference would be bigger. But this is not like the great value. I would say that great value is that Scala is really good at that you need to just write the logic. It really doesn't want any unnecessary code just to make something run. I'm not saying that it never happens, but I'm saying that it happens rarely, and these simple operations, as on the collections, there is a very strong API that you can do quite a lot, and it's quite nice to get used. It is a bit bigger and complicated, but that's all right. And so yeah, I will show you my functional library, because I have had a look at it, and again I was like, sequence okay, but maybe it can be set. There is some unit, there is some unit, there is some unit, there is some units. I want to borrow a book, and if I got the member, I'm borrowing a book. If don't, I'm just doing nothing, or I don't know what I'm doing. So this is kind of it feels for me like badly designed methods, really. So I wanted to do something smarter, something that I can see a bit more to it. So I wrote a lot more, of course, because, well, that's... And I created these results. And again, are they arbitrary? A little bit, I do agree, but this is about my control over the process. So what I did is that I again created the functional library object. So this is companion object, and I can use whatever is here, even if it would be private. I don't have private elements here, but yeah, this is kind of a connection between object with the static methods and the instance. So here I've got sealed trait, and yeah, I guess I didn't tell you what is sealed. Sealed is that this trait can be can be used as for extension only in this file. So you can use it outside. This is kind of like protected enum that I've got this library operation results, and I don't want my clients to create new ones. I want to have this control for myself. So this is useful if you are creating libraries, something for whoever to use, and you want to protect your code. So that's pretty useful. And I've got a result, and I've got success, which it is kind of generic. Yeah, the operation was successful, but for this piece of code, I think it is quite enough. And then I have some not successful results, and it could be like another one, library operation failure, and I would just inherit from that, but I don't need to. I'm a programmer. I want to decide what I want to have specified, what I don't want to have specified. I'm just creating some code. So success is something that, what you attempted to do was done, and it's all right. But then I can have something that member was not found. I wanted to do with some membership ID that I passed, or member's name, or whatever I wanted to do, but I didn't find the member, and the operation couldn't be done. So I'm having something for that. Also, there is member already present. I created sets of member because I don't want the one member multiple types. And also we are looking for a book, so we can not find it. And also the book that we are adding can be already present. And if I'm so special library that I've got just one piece of book in the library, then this is very useful. So let's have a little bit of look how it looks like. I a little bit mentioned that this is actually expression. This returns the library operation result. So I don't need to go like return. I can do this. I can super do this. Like return this present. I can give it semicolon, but IntelliJ is even smart enough to say this is redundant. You don't need to do this. I mean, and as I mentioned, you can use it, but then I think you are not designing the methods really in a way that Scala is built for. But of course, if you are trying something new, just play with it, how it works for you. I'm not here to judge. So we've got books, and we just check if our adding book. Then if we contain it, we don't want it. We already have it, and if we don't have it, then the operation is success, and we are just adding the book to the books. With the member, it is very much the same. The member is already present if we try to add the same as a member. But if it is not present, we will just add it in, and the library operation was successful. Borrow book is, from my point of view, a bit nicer. And not even like shorter, but of course I'm returning all this crazy stuff. But this is all just one expression. I'm just mapping and reacting on the functions and methods that were executed before. So first what I do, I'm finding the member by ID. This is just a simple filter. And then here I'm matching. And this matching you will see a lot when you try to read some Scala code, because this is exactly what this is returning. This is option, and option has two implementations. One is sum and other is none. As the name says, sum has some value, none is empty. This option is kind of like sequence with 0 or 1 element. So books contain something. We've got the members, so we can have a look at the books, and if we have a book in our books, we can just let the member borrow the book, and again get rid of the book in all our books in the library and return with the operation success. If not, here book was not found. So that is one information we can get. And the second one, member was not found. So that's that tells us a lot, I would argue. This was success, everything was all right, but I can just say to the client, this happened, this failed. I'm not throwing anything. This is the result that I'm returning. This is perfectly valid, the result, because I don't have every book and every member, but I can communicate very clearly. So with the return of the book, it is basically the same. I'm matching whether I have a member. If not, well, I'm returning I didn't find it. If I do, then member is returning the book, and I'm just getting it in. What I'm not doing here that what I could is add in the book. Yeah, this could be connected, but yeah, it doesn't need to also. So that's pretty much what I did on this functional library, and of course we will have our nice run of the main method, and then I also want to have nice run of my Scala library demo. So this is what we've got. Created library, we've got 3 books. Nothing like super. Yeah, I could create it a bit better names when I'm thinking about it, but never mind. That's my kind of creativity. So this is first member, this is second member. We edited 3 books, and we've got 2 members. What we can see here, there is a title 2, there is a title 3. Now what did happen? Author 1, author 3. So there is all the books. 1 to 3. So where is my book? There is our 1, 2, 3. I didn't remember. Oh yeah, of course, I borrowed the book. That's pretty sneaky for me. So I added 3 books. I added 2 members here. And then I borrowed one book. This member borrowed it, and I took book 1 with title 1, and that's why I have just title 2 and title 3. So the mystery solved. I borrowed the book. I list the books. I list the members. Members, there are 2 of them. They are not borrowed or anything. Member 1. Oh, member 1, and he even has, well, they even has borrowed books. So here is the borrowed book that I was looking for, and there is member 2 with no books. So books by author 1, I just filtered, so nothing too fancy. And by genre 1, I also have just 1 of those right now. And yeah, I mean, this is about the implementation, but right now I've got just 1 book of genre 1. The first book of genre 1 was borrowed. And yeah, I got 2 books, 2 members, and I returned the book. And at the last line, I got title 1, I got title 3, and our title 1 is back. So that's pretty neat. But hopefully nothing new. And in the Scala, it is very much the same. Yeah, it's a bit different as it is written, but books title 3 and title 2, nothing more. There is the member, and yeah, there is a difference that I don't have. No. Yeah, member doesn't have the borrowed books as a part of the instance. It is actually the value inside. So I don't see the books as I see them in here. So yeah, there is one book for author 1, one book for genre 1, 2 books and members exactly the same. And here after the return that I did, we have this title 1, title 3, and title 2. So this is very simplified view of how do we work with Scala. I mean, it is similar in a lot of ways. And syntax, you can learn syntax in few days if you look at it. I mean, it's not super complex or anything, and you can write any code you want. But the real difference is how you think about the implementation. And if I would be working in Java for a long time, I would for sure work in some crazy functional way, and I would have some kind of constructs that would not be used in Java development, but it would resemble what I use in Scala, and I will try to push it there. And the same thing I saw a lot of times with my colleagues that came from Java background, that they tried to work with Scala, and it works. And so it kind of was what the business wanted, but in the long run, there was some hidden thread holes with kind of implementation with mutability, which is kind of hard to track maybe in multi-threaded systems. And all of that is a bit easier when it comes to Scala, at least for me. And of course, I'm biased as hell, so don't take my word for it. I just show you how I just created some very simple code in Java and compare it to something in Scala. And even, I didn't just leave it as to have two same implementations. I wanted to show you how would I do it to think it as a Scala developer, not just writing the syntax. So yeah, we can definitely go back there. But yeah, I want to thank you very much, because this is quite a long talk, and I'm happy that you stay with me. And now I think we can have a look at some questions.
Thank you, Tomáš. Thank you, colleagues. So I can see that we have quite a lot of questions in the chat, but Tomáš, I know that some of those were addressed by you already. So I will read them out, and once you understand that that's something we already talked about, just tell me skip, and we'll move ahead to the next one.
Right.
So the question was on the very beginning of your talk. Does it still make sense to learn Scala? And if so, is it better when using Apache Spark or use Scala or Java?
Oh, this is very hurtful question, Pavel. But yeah, absolutely. I think that on JVM there are actually quite a few options how to get to a bit more easier, like functional way. Scala is quite a nice language, and well, as I presented, yeah. With Apache Spark, of course I use Scala because I'm a Scala programmer, and I find it that the project that I'm working on is not using the Scala to full extent. So I'm yet to be like discover the full power of Scala with Apache Spark. But yeah, it is very much chaining the methods in Apache Spark when you work in Scala, and you are just kind of creating this blueprint of your operation. I didn't see too much of Java with Apache Spark, but yeah, Spark is something that I'm a bit new to, so I wouldn't answer. But I mean, Spark is created for both languages, so I'm sure it is usable very much for both, but I would argue that both types of programmers are thinking a bit differently when using it.
Thank you, Tomáš. We have another question from Kutagula. I hope I'm spelling him correctly. Is it good practice to write in camel case?
It is best of practices. I mean, in fact, it depends on your project. When you came to project and they are using underscores or whatever else, then the best way is to, well, not to run away quickly, but to follow the historical standards that the project has. But on all the projects that I had been on, the camel case was way to go. So this is pretty much standard.
Thank you. So Jay is also asking, in Scala, is there any other data structure similar to list which might be immutable?
We got them all. We've got, well, sequence is kind of a trait or interface that you can use for a lot of type, but you've got sets, you've got lists, you've got maps, you've got arrays. Even this option type is modeled in this way. So there is a lot, and I really recommend to have a look at the Scala collections and collection APIs, because this is quite a strong part of the Scala. So this is quite nice to use.
Thank you. And the final question in the chat from Peter. How do imports work in Scala? I only noticed a couple of imports from your own classes.
Yeah, absolutely. I mean, I don't think that there is like difference between how the imports work. You import the package, another package, then there is well, model is package for my models. And I have this well, it doesn't matter too much, but members, model, and you've got here books and member and library. So I'm just having it like this. You can do a bit of fancy thing here, and maybe you can do it in Java. I don't know. Please write in if we can. But you can do. Oh, I didn't even need to do that. So sorry for that. You can do like word favorite member model. So you can locally rename your class. So sometimes when you are using a lot of models for multiple reasons, and you got some kind of like layer of business logic that connects them, you got like some read model and some business model or whatever, then you just can distinguish like this, or you can even distinguish like, this would work. I think so. We can go like basic, can go model, and this is exactly what I'm talking about. I would import it like this, and now I can create basic model book, and it would be exactly what there was like title 5 and author author 6, and the year would be whatever. So you can reuse the models like this. This is kind of neat thing. This is a bit niche. I mean, I can use it, of course, but yeah, and here, yeah, we don't have the member now, so it asks me whether I want this members model member because I just renamed it. So let's get rid of that. So the compiler is happy. So this is what's going on.